Welcome back to another A Level Maths revision video. In this video today we're going to take a look at some second year material, which is looking at the geometric series. So follows on from kind of like the arithmetic series and recurrence relations. Again, nothing too intense here. A lot of formulas are given, so hopefully we shouldn't find this too tricky. So let's take a look at some of the questions. For each question I've included the formula that's given in the formula book, so hopefully we can follow along together. So this first question then, I picked a nice one to start with, just basically here, just applying the formulas. So question 2, part A, we want to find the common ratio. So remember, the common ratio is just what we multiply each term by to get the next term. So we're told the fourth term of a geometric series is 10, the seventh term of the series is 80. Can we find the common ratio? Well, remember, if we've got, for example, the fourth term and the seventh term here, we need to use the nth term notation. So remember, the nth term, so nth term, that's just given by AR to the n minus 1. Okay, so we're going to use this now, where we know the fourth term is 10, the seventh term is 80, using this now to find the common ratio. So in that case, the fourth term, that would be AR to the 4 minus 1, so AR cubed, that's equal to 10. We've then got the seventh term, so that's going to be AR to the 6, which is equal to 80. So at this point now we need to find R. There's a few different ways you can do this. You can do AR to the 6 divided by AR cubed, and that's equal to 8 divided by 10. You can do it like that. The way I like to do it is rearrange in terms of A and then substitute A into one of the other equations. It doesn't matter which way you actually do this. But for me, I think the easiest way is to rearrange this one here. So that would be A is equal to 10 divided by R cubed. Okay, so 10 divided by R cubed. So then I substitute this A into this equation here. So that's going to be 10 over R cubed times R to the 6, and that's equal to 80. Okay, so just substituting into here. We can start simplifying, so 10 over R cubed times R to the 6, so that'll cancel there, and that'll become a power of 3. So what I've got then is 10R cubed is equal to 80. I can divide both sides here by 10, so I get R cubed is equal to 8, and then take the cube root of both sides. So R would be equal to 2 in that case. Okay, so we know that's our common ratio. Bit of common sense here. If the fourth term is 10, the seventh term is 80, clearly our common ratio here should be positive. Obviously, so that kind of gives us a bit of an idea there that we're right. Part B, we want to find the first term. So in this case, we just want to find A. That's what we're looking for here. Remember, A represents the first term of the series. So if we're looking to just find A, you can just substitute it back into either of these. You can either substitute it into AR cubed using R is 2, and that's equal to 10, or you can sub it into AR to the 6 equals to 80. To me, it makes more sense to sub it into the first one because we know what R cubed is. So A times A is equal to 10. Okay, so AA is equal to 10, and then in that case we divide both sides by 8, so we get A is 10 over 8, which we can write as 5 over 4 there. Okay, you can give it as the decimal equivalent if you'd like, but A equals 5 over 4, job done. And then finally, for part C, we want to find the sum of the first 20 terms here. So if we do it over here, underneath the formulas, so we're looking to find the sum of the first 20 terms. So we're using S20. So in that case, we're using this first formula here, replacing n with 20. So that's going to be A, which is 5 over 4, times 1 minus R. Remember, R is 2, so that's 1 minus 2, and our n is 20. And then we divide this all by 1 minus 2, because R is 2, so minus 1. And at this stage here, this is just plug it into your calculator and see what you get. What you should get is 1310719. Okay, so that's our sum there of the first 20 terms, and that's to the nearest whole number there, like we're asked to in the question. So like we're saying, for the first 3 parts here, just basic applications of formulas and getting used to it. Next question then, same ideas again, pretty basic, but you know, a little bit unusual in kind of how we're asked this. So we're given a geometric series, we're given the R, the common ratio, and we're told it has a sum to infinity of 10,000. So part A then, for question 6 here, we want to find the first term. So we're looking to find A here. We know R is minus 0.9. We know, and then the sum to infinity is 10,000. Now we know the formula for the sum to infinity, so that's given here. So we're going to we're going to use that formula in a moment to help work out what A is. So in that case, we know the sum to infinity then is 10,000. So like we just said, we're going to use this formula now. So that's going to be A divided by 1 minus R. But remember, we know what R is. That's minus 0.9. So that's 1 minus 0.9. So we're adding 0.9 there. And we know that this is equal to 10,000, like we told in the question. Okay. At this stage here then, we're just solving this. So this would be 1.9 for the denominator here. So to solve this in terms of A, we just multiply both sides by 1.9. So A is equal to 1.9 lots of 10,000. And in that case, we get that A is 19,000. Okay, so that's our first term there. Part B, we're asked to find the fifth term. So again, just using basic formulas, basic understanding of the geometric series. If we want the fifth term, we're using nth term notation. So that would be AR to the 4 then. Okay, we've got A, so let's just write A at the top. It's 19,000. So summing everything in, that's going to be 19,000 times R, which is minus 0.9. And we raise that to the power of 4 here, like we can see. Okay, here, plug all this into your calculator, see what you get. And what you should get here is, what do we get? 12,465.9. Okay, so that's our answer there for the fifth term. And then finally, we're asked to find the sum of the first 12 terms, giving this answer to the nearest integer. So if we do that over here again, so that's going to be S12, so the sum of the first 12 terms. And again, we're using this formula this time, okay, so the top one. So we know what A is, that's 19,000. Times that by 1 minus R. We know R is 0.9, so that's minus 0.9 here. So just be careful here, don't try to start simplifying minuses of minuses, just plug everything in as it is. So minus, bracket, minus 0.9 to the power of n, so that's the power of 12. Close that bracket. And then we divide this by 1 minus R. So you can do it here in the denominator. The only reason I don't do it here is obviously this is dependent on the power here, on whether that's even or odd. So 1 minus R, so that's 1 plus 0.9, so 1.9. Here now, this is just plugging into your calculator and seeing what you obtain. So I've written it somewhere, yeah, there we go, 7,176 to the nearest integer. Okay, it's to the nearest integer. That's an n, believe it or not there. Pretty terrible, but there we go. So that's that full question done there. The next question then, we're starting to take a look at some more kind of tricky material. You know, getting used to some of these tricky questions like we can see here for part C. So, the first 2 parts are again pretty standard, just what we've been doing. Question 9a. We're told the first term of a geometric series is 20. We know the common ratio is 0.9. Can we find the value of the fifth term? So the fifth term, again, just using the nth term notation. So that's going to be AR to the 4. We know A is 20, so that's going to be 20 times R, well that's 0.9, and we raise it to the power of 4 here. Plug this into your calculator, and what you get here is 13.122. Okay, so that's our fifth term there. Part B then, we're asked to find the sum of the first 8 terms. So that's the sum to the first 8 terms here. So we're just using this formula here. So if we do that, that's going to be A. So what's our A? So let's just write everything at the top. A is 20. R is 0.9. So plugging everything in here, that's going to be 20. 1 minus R, which is 0.9, to to the power of n, so that's to the power of 8 here. We divide this all by 1 minus r, so 1 minus 0.9 gives us 0.1 there. Plug all this into your calculator. Let me just double check it, 'cause I think I might have done it wrong on my original working. Let's just double check this. So let's just double check 20, 1 minus r. Yeah, everything looks good. So let's just double check this on my calculator. 1 minus 0.9 to the power of 8 times 20, divide that by 0.1. So I've got 113. So one decimal place, that'll be 113.9 there. Okay, so that's the sum of the first 8 terms. C then. So I'm going to clear here just for part C because it's quite a long question. So we'll clear everything for part C. Let's have a look at this one, quite a tricky one. Part C then. We're told that the sum to infinity minus the sum to n terms is less than 0.04. Okay, now we're using it for this same series here, so we still know a is 20 and r is 0.9. Okay, so we've still got this part of this bit of information here. So we've now got to figure this out, which is going to be in part D, but for part C, it kind of helps us get towards that stage. We need to show that 0.9 to the power of n is less than 0.0002. So let's break this down. Let's work out the sum to infinity first, because for the sum to infinity, you only need a and r, which we have both of. Okay, we've got them over here. So the sum to infinity then, that's going to be a, which is 20, divided by 1 minus r, so 1 minus 0.9, minus the sum to the first n terms being less than 0.04. So that's 20 divided by 0.1, so that's the same as times in 20 by 10. So that's 200 minus Sm being less than 0.04. Okay. At this stage here now, we need to start basically working out the sum to the first n terms. Now obviously we don't know what that is because it's dependent on what that n value is. And that's what we work out in part D. So at this stage here, we just work out as far as we can using n terms. So what will that look like? So it'd be 200 minus a, which is 20, 1 minus r, so 0.9 to the power of n, close that bracket, and then we divide it by 1 minus r, so 0.1. And we know that's less than 0.04. Now at this stage here, if you think about how this fraction works, so ignore the 200 at the front, ignore this 0.04 for now, just focus on this 20 bracket 1 minus 0.9 to the n divided by 0.1. This full expression first, let's deal with this fraction here. So if we divide it by 0.1, that's the same as times in the full thing by 10. So what I've got then is so let's do it at the top here. I've got 200 minus, so 20 times it by 10, and we've got the full expression there, so it's going to be 200 lots of 1 minus 0.9 to the n being less than 0.04. Okay, now imagine you expanded this. I've got 200 minus 200, and then minus of a minus is going to become positive. So what I end up then with is 200 lots of 0.9 to the n. Okay, and this is all less than 0.04. 200 minus 200, so they'll just cancel. So I get left with 200 lots of 0.9 to the n being less than 0.04. Then at this stage here, we can divide through by the 200, and then we're going to obtain 0.9 to the power of n, which is exactly what we want to show for part C. So then we do 0.9 to the power of n being less than 0.04 divided by 200, which gives us 0.9 to the power of n being less than 0.002. Okay, which is what we need to show for part C. Okay, so that's 4 marks there. Like, see, quite a bit of working. Just got to be careful at this stage here. I think this is kind of like the trickiest part, going from here to this line here. Okay, so that's part C. And then finally for part D, we want to just work out the smallest possible value. So using some other areas of A Level Maths that we've worked out, hopefully it kind of jumps out here. So with this kind of inequality, how do we solve it and work out the smallest possible value for n? Well, with it involving powers, the most obvious step here is using the logarithms. So if I take logs of both sides here, so I'm going to take the natural logarithm, so that's ln of 0.9 to the n being less than ln of 0.0002. Then at this stage here, we're going to use the power rule to bring that n down. So that's going to be n lots of ln 0.9. And the same over on this right hand side. Can't do anything with that here. And then finally, if we just want n as an inequality, we divide through here by this ln 0.9. But we've got to be very, very careful here. Double check what ln of 0.9 is on your calculator. And what you'll obtain is that it's actually less than 0, it's a negative, right? And remember, when we have a negative here, like this with the inequality will flip, because we're dividing it by a negative number. So n in that case has to be larger than ln 0.002 divided by ln 0.9. Okay, this happens here again just because this is less than 0, it's a negative number. Now if you plug this into your calculator, what you obtain here is that n has to be larger than 80.83, so on, so on, and so on. But we want the smallest possible value for n. So you just got to be careful here. N isn't 80, but n has to be 81, because we're technically we're over halfway through this 80.83 value here. So the next possible value is 81 then. Okay, so 81 is the smallest possible value of n there. Okay, so like you see, quite a tricky question there, but hopefully not too bad. But if there's anything that's unclear, like always, just leave a comment down below. And then let's take a look at the final question here. So we've got the kind of question here that's dealing with a bit more kind of context with it. So we've got a company that predicts a yearly profit of 120,000 in the year 2013. They predict that the yearly profit will rise each year by 5%, so quite ambitious. And they're predicting the yearly profit forms a geometric sequence with common ratio 1.05. So let's write down our A and our R. So what's A? Well, A is just our first term in the sequence, which, like we can see here, is 120,000. Okay, so that's just A. R, the common ratio, we're told that in the question that's 1.05. So nothing extra to do with that. So at this stage here then, now we can start applying all our formulas that we need. For part A, we're asked to show that the predicted profit in the year 2016 is 138,915. Well, how do we do that? Well, let's just consider how this model actually works, this series. So the first term, A, is for 2013. That's our first term. So then the next year, 2014, that will be A times by the common ratio, AR. And this pattern keeps going, because it is a geometric series, that's what we know, right? So the next term, so that will be for the year 2015, that will be AR squared. And then finally, 2016, that's the year we're asked to work out, that's AR cubed. Okay? So we need AR cubed. We've got A, we've got R, just plug it into this. So AR cubed is equal to 120,000 times R, 1.05, to the power of 3 here. Okay, plug it all into your calculator, and we get exactly what we're asked to get here. So we get 138,915 as required. Okay, so quite a nice start off there. Part B then, again a little tricky, kind of similar to the last one here, where we're kind of looking at the powers. So this is what makes it a bit more difficult. Part B, so we're asked to find the first year in which the yearly predicted profit exceeds 200,000. So if you keep going, so for example 2017, what's that profit? 2018, what's that profit? We're looking for the first year where the profit is larger than 200,000. So we require, in that case, our nth term to be larger than 200,000. That's AR to the n minus 1 being greater than 200,000. So at this stage here now, we need to work out n here. That's what we're looking for. We're looking for that value of n, because that gives us the year. Well, we know what A is. That's 120,000. We also know what R is. R is 1.05. So we can start plugging things in. So first thing I can do is divide by this A. So I get R to the n minus 1 is larger than 200,000 divided by A, which is 120,000. Plug that into your calculator, see what you get. So what we get is R to the power of n minus 1 is larger than 5 over 3. So that's just our first step. And don't forget, we know R. So we know that R here is 1.05. So this is 1.05 to the n minus 1 is larger than 5 over 3. And then at this stage here, just like the last one, we're going to use logarithms. So we need to find what n is. So at this stage now, taking logarithms here at both sides. Again, I'm going to take the natural logarithm. So I get ln. And again, I'm going to kind of skip the step here. I'm going to bring this n minus 1 down straight away. So it's going to be n minus 1 ln 1.05. Okay, and that's larger than ln 5 over 3. Now, we just want n minus 1. So in this stage here, just divide through by this ln 1.05. So n minus 1 is larger than ln. And here, we don't need to flip the inequality because ln 1.05 is larger than 0. So it's not negative, it's positive this time around. So I'm kind of running out of room, but hopefully you can still see 1.05. So at this stage here, what we get is that n minus 1 is larger than 10.469, blah, 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 so on, so on, so on. Now we just want n, because once we've got n, we then know the first year in which the profit will exceed 200,000. So I need to add 1 first to both sides, so n is larger than 11.469, so on and so on. So at this stage here, just like the last one, we're partway through the 11th year, so it won't be the 11th year, but in that case it would have to be the 12th year. So n equals 12. So that's the 12th year. So if we start here on 2013, we're looking for the 12th year, including the year 2013, the 12th year then would be the year 2024. Okay, so that's the first year in which the yearly predicted profit exceeds 200,000. And then finally, we want to find the total predicted profit here for the years 2013 to 2023, inclusive. So part C, so again, this is a summation question. If we're including the years 2013 to 2023 inclusive, then that's going to be the sum of the first 11 terms, or the first 11 years. So in that case, that's going to be A, so 120,000, times 1 minus R, so 1.05 to the power of 11, and we divide all of this by 1 minus R. Okay, again, like always, plug this into your calculator, see what you get. So this would be in pounds, because we're working with money, and obviously it gives, we're asked to give the answer to the nearest pound. So that's going to be 170.4814. Question done. And there we have it. So that's geometric series and sequences wraps up there. Hopefully not too bad, but these parts here can definitely be the trickiest parts for this topic. But like I said, brings us to the end of this video. If there's anything that's unclear, like always, just be sure to leave a comment down below. Hope it's helped. Yeah, cheers.